and welcome to Nova Incorporated. If you're watching this, then you must be one of the new reactor operators that got stationed at the North Shore Mountains research site. This tape will provide you with a comprehensive guide on the protocols and operations of the Laser Injection Energy Capsule Reactor Mark II. This tape will be divided in 4 chapters. 1. Reactor, logistics and components. 2. Normal operations outline. 3. Maintenance procedures. And 4. Emergency protocols. Please pay attention during the entirety of this tape, as one single mistake in operating the reactor may lead to unforeseen consequences. Let's begin. All right, let's begin. Chapter 1. Reactor, Logistics and Components. Reactor Containment Structure. The primary reactor containment structure is made up of a man-made variation of tungsten capable of sustaining temperatures beyond 5,000 degrees Kelvin as long as it is in a ventilated environment. The structure consists of a ventilation module on top, coolant, pressure, and hydraulic lines at the bottom, and injection ports all around the central portion of the structure. The rear section of the reactor is where the structure's access point and electrical lines are located. This is where both maintenance personnel and electricity can enter the containment structure to serve their purpose. Fuel capsules. The containment also houses 4 fuel capsules embedded into the main reactor vessel that can be removed and replaced when necessary. Each capsule is made up of xanthan 240 as well as a noble gas to stabilize the unstable compound. Specialized fuel cells may be inserted for experiments or for a boost of power. Power lasers. Around the containment structure are 8 power lasers which send a combination of xanthan 104A, a failed and less reactive iteration of xanthan 240, polonium and francium. Each laser is powered by electricity provided by the North Shore Mountains external grid and is capable of operating up to temperatures of 500 Kelvin. However, the limit may be exceeded a slight bit if required. Attention! Exceeding the operational temperatures of the power lasers is not advised and may cause power laser damage. Thermal systems. The reactor is capable of operating at moderately high temperatures compared to others, and thus requires efficient thermal systems to operate safely. Thermal systems for the Laser Injection Energy Capsule Reactor include climate control units are large passive heat exchangers mounted on the chamber walls. Each unit is cooled by coolant and can operate at any temperature the reactor may be exceeding. They also contain radiation dampeners capable of removing deadly radiation from the chamber if radiation levels exceed safe limits. Ventilation units are smaller units mounted between each power laser set. They remove hot air from the chamber passively and work well with the ceiling-mounted chamber fan, as activating the fan and units can cool the chamber down within a few minutes. The chamber fan works to help blow cooler air into the chamber to ventilate the Laser Injection Energy Capsule Reactor. Both the motor and the fan need to be on for the fan to be cooling. Power of the fan can be modified between 4 stages. The coolant loop helps to cool down the Leica directly. Cooling pumps must be on, coolant must be in the tank, as well as the primary and superstructure valves open. Coolant efficiency drops as the coolant loop remains on, so turning the loop off every once in a while won't hurt. Coolant flow power is adjustable in 4 stages. The cooling tower is a boosting system for the coolant loop to provide additional cooling for the coolant and the Leica.